Hi, John McPhail here from Matex Control Chemical in Calgary, Alberta, Canada. I'm going to introduce to you here one of our products that we manufacture here in Calgary. This product is called TriLube. It's an environmentally safe water-soluble lubricant for lubricating air-bearing tricone bits, specifically manufactured for this particular application to lubricate the bearings of these bits. This is a typical injector for injecting the TriLube, and we've always found that if we inject TriLube with an injector versus mix it in the water tank, we have much better control of our injection rate and our consumption of the product. Here you're seeing when it's injected, it's coming down through the drill pipe. It'll lubricate any stabilizers, roller stabilizers that might be on there. It comes down through the airways. And this is just showing exactly where the product goes. It follows the air path that travels on through. It comes down in through the middle to the hard metal inlay and to the snoozy button, or the carbide insert that's pressed on the inside of the cone itself. So that's just a good blow up to show exactly where the product is going. And it also, when it climbs out out through the back where the air releases, the product goes out there. And it also, if you have a little bit more in there, then you'll also coat the cutting structure as well. Here is a typical, we call it the two typical causes of bearing failure, but it's also the results of bearing failure. Is when the bit starts to core, and it also, when it starts to core, the cones will move back from the outward thrust, from the downward pressure of the outward thrust pushes the cones back. And when the bearing starts to go, and especially that, you can see in this one here, the carbide insert that was pressed into the cone itself is gone. So these cones have since moved back, and it's done two things when it moves back. It changes your cutting pattern, and it also comes back into the shirt tail here, and you can see where it's affected the metallurgical in the shirt tail here, and when it starts to change things in the metal, it spits it out in chunks. So basically, as the cones push back into this shirt tail, you can see where the shirt tail has basically machined a race in the back side of this cone, and as it's doing that, it's changing the shirt tail again. So when it spits this metal and such out, it allows dirt and such to come into the bearings when you turn the air off. And so as we get dirt in the bearings, any water, especially in copper mines and such, where the water is so acidic, it gets in there, and you change out your connection, put another drill pipe on, start to drill down, and it'll start to deteriorate those bearings very, very quickly. So then we're looked like this. We're left with something like this, where you can see the shirt tail is gone here, and it's machined a race in the backside of this cone, and the cutting structure is all still in pretty good shape, as well as the gauge protection. I mean, it's all in good shape. This bit would continue on a lot further if the bearings had stayed intact. And again, with the cutting structure being there, the cutting pattern that we're looking for when we're manufacturing these bits, it changes two things. It not only increases the life of the bit, but it drastically can increase the penetration rate of that particular bit. This is two different bits that we had run down in southern British Columbia in a coal mine a few years back. I had run two bits side by side on the same bench, same pattern, one without TriLube and one with TriLube. The one without TriLube, as you can see here, it finished up at 1,800 meters, and that's an average for that average bit life for that mine site. The one that we put TriLube on, we ended up with 5,800 meters. So you can see it's a 4,000 meter increase, only because we kept the bearings intact. When these two bits were finished, we had taken them to a metallurgical engineering firm in Calgary. I had asked if he could give me a report on the bit failure, as to what caused this bit to fail, not telling him that we had lubricated one of these bits. So the results were where this bearing, you can see we had the bearings had failed. This is the actual other side of this cone. The cutting structure is in fantastic condition, but as this cone, from the outward thrust, as it was pushed back, you can see it's where it's machined its race in there. You can see the rust and such that's on the inside of this cone, and the cone itself is, if it was good on the inside, we could put that back on another bit and go drilling and make some meters. Where this is, and that's the 1,800 one without the TriLube. The one with the TriLube, the 5,800 meter one, You can still see, if the camera's picking it up, how shiny it is on the inside. And if you look at the back side of this cone, it's still in perfect shape. It never come back and touched the shirt tail. So it was also kept its penetration rate up because of the cutting pattern was kept in place. I think this picture is probably too dirty to see, but these teeth are all broken, and the reason this bit come off is because the teeth of the cutting structure was finished and it wouldn't drill anymore. But credibility to the bearings. So from those two bits, when I went to pick up the report from the lab, these two pictures were sitting on the desk. And I asked, what are these two pictures for? And he said, well, John, if you look at how this bit is manufactured, the leg here, as it comes down, this black part here is a hard metal inlay. So it's a hard metal that's welded in there, here, and then it's ground off to precision. And this is a carbide button that's pressed into the cone here, as I touched on here a few minutes ago. And he said, if you take this leg off these two bits, this is the one with 1,800 meters here, this is the one with 5,800 meters here. If you take those and cut a sliver off, a fine sliver, and x-ray them as if you were x-raying a tooth at the dentist, then this would basically be the filling in that tooth, which is this hard metal inlay right here. So as you can see, the 1,800 meter one, the hard metal inlay is gone. And he couldn't explain this to me, because bit number 2 with 5,800 meters, that hard metal inlay is still there. So it's showing that we kept the bearings intact. The cones actually never walked back. They never moved back. So again, keeping its cutting structure, the cutting pattern in place. So if we move over here and just have a quick look at this cutaway, what it's going to show us is this is the green TriLube that's coming down here because this product's environmentally safe. So what we're looking to do is get this TriLube down here to the bottom, right out to the front, and that area right there, that small space between the hard metal inlay and that button, if we can lubricate that with a product that leaves a film strength in excess of 100,000 psi, right there at that point, then it doesn't allow this cone to slide back into the leg. It doesn't allow right here to touch the shirt tail. It keeps the shirt tail intact. However, it gets there, then its only escape route to get out, as we all know, is over the top of these bearings. And then it's blown out through the back side. So if we're looking at approximately 25% of the air to come down in through here to keep the bearings clean and cool, then why not throw a little lubricant in there, such as TriLube, something that's been manufactured specifically for this application, get it in there and get those bearings coated. This here actually becomes the result of this right here. We've done it numerous times. We've been doing it for quite a few years. As a matter of fact, here's a testimonial from 1991 at Westar Mining, which was a mine down in southern BC, is now owned by Fordia, or by Fording Coal. And this letter was written in August 23rd of 1991, and stating that they had received 100 to 175% increase in their bit life at that time. So that was 1991. This is bringing us up to 2011, 2012, 2013. This is just some reports that we had got back recently from an unnamed property, and not sure whose bit this was, but you can see right here is when TriLube was put in. So we have a very good graph going back for the last couple of years and knowing exactly where our footage has been, and then you can see when TriLube was introduced, it's gone right up, and it's stating that we have received a 41% improvement in bit life versus the last 30 bits before implementing TriLube. So there's a very good testament to it here. Here's another mine that's just very, very recent. This is in 2013. You can see the graphs as it's going along. You can see where they've introduced the TriLube, and we're showing a 38% increase there. So when you start looking at your average life and your increase to date, you can figure out your cost per foot very, very quickly. Before it was 36 cents per foot. Now we're getting 26 cents per foot in this particular mine here, and so that's 10 cents a foot. You can figure out your savings over the period of a year, and that's after the cost of the product itself. Because when we go into a mine to have a look to see what what our actual percentage break-even point might be, we just have an Excel spreadsheet set up here so you can just change your numbers in the blue, and these numbers are just numbers there for the sake of showing you how the program works. But we can throw our numbers in our blue, put our percentage increase in here to find out where our values are, and put your number of drills in there, and you'll see your savings per year. And I mean, it can be into the hundred thousands of dollars very, very quickly. This is a nice little video that I like to show because this TriLube is a water-soluble product, and this is goldfish here. The fish are swimming in the water with TriLube already in it. This is just a drop of the product before you mix it into in with the fish. This was a couple of years ago that we did this, and here's the fish today. You can see that they're growing and they're still very, very, very healthy. They are a very good testament to the environmental, as to how environmentally safe this product actually is. This is our website, matex-ccc.com, where you can get on there and find any of our other environmentally safe products and lubricants. Thank you for watching.